Welcome class 11th in the series of distance time graph. Let's move on the first topic, slope of the distance time graph, which is equals to speed. So as you can see, there will be a x and y axis we have. It is a distance axis and it's the time axis. If the distance and time axis will be a straight line graph, then it's showing it's a uniform motion. So equation of straight line graph is y is equals to mx plus c, where c is the intercept. So y is equals to mx plus c. In this particular equation, m is defined the slope, and the slope means y by x, which is equals to tan theta. Means we can directly write as on like y by x, which is defined by the m, which is defined as a speed. So speed is equals to r slope, which is m. Position time graph. So case 1, as you can see, this will be a position time graph. We can take different also. So slope of position time graph defines the term velocity. So as you can see in this graph, firstly, that particle will be moving 2 kilometer in a 2 hour, okay, like h to m. This will be, I'm taking as h, this will be m, and then after m to h. Speed of position time graph, this is the case 2. So slope again defines the term velocity, and mdt defines the term speed, and mpt defines the term velocity. So slope is equals to slope 1 plus slope 2, and the resultant slope will be 0. So velocity of the slope will be 0. Interception from different position time graph. So case 3 we have, as you can see, there will be the graph line not passing from the origin. They have some separate line which is passing from the one. So body is at rest for a one first hour. Uniform motion after that. So interception from the different position time graph will be case 4. As you can see here, the graph will be straight line. So we can say this motion is a uniform in nature. But after 2, as you can see, there will be a random motion of the graph or randomly graph start to make it. So we are saying as a random motion or a non-uniform motion. Towards the end, at the rest, there is a no motion. Now let's move with the some multiple choice question. The slope of the velocity time curve at any instant of times gives displacement, velocity, acceleration, or retardation. The correct answer of this question is acceleration. Second, the slope of position time graph gives speed, acceleration, retardation, or velocity. The correct answer is the velocity. Third, the slope of distance time graph gives the acceleration, retardation, velocity, speed. So distance time graph gives the speed. In the relation to a velocity time graph, the first, the curve can be circle. The area under the curve and above the time axis between any two instants gives the average acceleration. The slope at any instant give the rate of change of acceleration at that instant. The area under the curve and above the time axis gives the displacement. The correct answer is D. Next topic is average speed and velocity. So average speed and velocity. Average speed is equals to measured of total distance covered to any given time. Like average speed is equals to total path length divided by total time interval. And in the case of average velocity, measure of the total displacement covered in a given time. Average velocity is equals to total displacement divided by total time interval. Position time graph for an object. So if the graph is in a straight line, moving object will be positively velocity. If the graph will be going downward direction, that means moving with the negative velocity. And if the displacement not changes or position not changement, that means object is at rest. Now, instantaneous speed and velocity. It measures the distance covered at any instant of a time. Instantaneous velocity measured measure the displacement covered at every instant of a time. Now instantaneous speed is same like that. Let delta x be the distance traveled by the time interval t, and it changes t plus delta t. So the average speed in the interval of v average is equals to delta x by delta t. As delta t approaches to 0, the distance delta x also approaches 0. But the ratio delta x by delta t has finite limit, which is v is equals to limit delta t tends to 0, delta x by delta t. Average velocity is equals to net displacement divided by total time taken. So instantaneous velocity gives like let delta r is the displacement in the time interval delta t. The instantaneous velocity vector v of the particle at time t is vector v is equals to limit delta t tends to 0 delta r divided by delta t. So this will be gives d vector r by dt. Average speed and average velocity. Average speed is equals to total distance divided by time, which is equals to d by t, and average velocity is equals to total displacement divided by time, which is a d by t. So how is average velocity different from the instantaneous velocity? The answer is simple, because the average velocity does not give any detail about the motion of the particle. It gives only the result of the motion. Okay, but in instantaneous velocity, it defines how fast the particle move at a particular distance of at a particular instant of a time. So more information we will get in the instantaneous speed, and means instantaneous term. Linear motion. So for linear motion, average velocity is in the form of simple like a s1 plus s2 plus s3 divided by t1 plus t2 plus t3, which comes like v1 t1 plus v2 t2 plus v3 t3 divided by t1 plus t2 plus t3. And if a body travels with a velocity v1 for the first half of the journey time, and with a velocity v2 for a second half of the journey time, then the average velocity v is equals to v1 plus v2 by 2. Third is if a body covers first half of its journey with the uniform velocity v1 and second half of the journey with uniform velocity v2, then average velocity v is equals to 2v1 v2 divided by v1 plus v2. If a body travels first one third of the distance with a speed v1 and second third of the distance with the speed v3, then average speed is v is equals to 3 times v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. Now let's move on to some multiple choice question. The dash defines how fast the particle moves at a particular instant of time. Average velocity, average speed, instantaneous velocity, instantaneous speed. So the correct answer for this question is instantaneous velocity. Next, The dash does not give any detail of the motion of the particle. It gives only the result of the motion. Average speed, average velocity, instantaneous velocity, or instantaneous speed. So the correct answer is average velocity. Now moving ahead with the topic acceleration. So what do you mean by acceleration, students? It's nothing but the rate of change of velocity with respect to time. That is, A is equals to dv by dt. It is a vector quantity. As you can see, if I just want to plot this acceleration graph, so there will be various graphs we can get. And again, the slope of tan theta gives velocity time graph. Tan theta is equals to v2 minus v1 divided by t2 minus t1, which gives A. So we can say as A is equals to Vf minus Vi divided by T, where Vf is the final velocity of the particle and Vi is the initial velocity of the particle. Position time graph for the accelerated motion. So as you can see this graph is a positive acceleration. This have a negative acceleration and it's for a zero acceleration. Okay. Next, acceleration is equals to 0. For example, what is the mean of that? A car is at rest. Velocity is equals to 0, hence acceleration is equals to 0. One thing more we can do, like car is in uniform motion, that means constant velocity. So for that scenario, like Vf minus Vi divided by T, here we can say Vf is equals to Vi. So in that case also acceleration must be 0. Velocity time graph for motion with constant acceleration. So from here we can also create the equation of motion also. So motion in positive direction with positive acceleration is here. Second, motion in positive direction with negative acceleration. Third, motion in negative direction with negative acceleration. And as you can see here, motion of an object in negative acceleration changes the direction with respect to t. So between the 0 to t1, as you can see, it moves a positive x-axis, and between time t1 to t2, it moves as a negative. Average and instantaneous acceleration. So average acceleration, change in the velocity divided by time elapsed for the complete journey, which gives the instantaneous acceleration. So rate of change of velocity at every instant of a time. Area under the Vt curve is equals to displacement. Simple case, object with uniform velocity. So area under the curve gives the area OABC, which gives OA into OC. After solution, we get time into velocity, which is displacement. Now conclusion for PT graphs and VT graphs. Slope of PT graphs gives velocity. Slope of VT graphs gives acceleration also. So area under the VT graph for uniformly accelerated motion is equals to displacement. So here we have a multiple choice question. Acceleration is a dashed quantity. Scalar, vector, neither is scalar nor vector. Both is scalar and vector. So the correct answer is a vector. The distance covered by a moving body is directly proportional to the square of its time. The acceleration of the body is increasing, decreasing, zero, constant. So the correct answer for this question is a constant. Now from here we are just going to start kinematic equation for uniformly accelerated motion. So this topic we will do in the next video. Till that, if you have any doubt, so you may ask in this chat session. Or thank you for watching this video. Take care of yourself, students.